Hello everyone and welcome to today's Crush the MCAT lesson on Math Fundamentals. Let's start first with slope. Slope describes how steep a line is. You may hear slope sometimes called rise over run, and this is because slope is calculated as the change in y over the change in x. We can see this in our equation for slope in the top right, m equals y2 minus y1 over x2 minus x1. This can also be said as m equals delta y over delta x. Let's take a look at some general examples of this now. A positive slope means y increases as x increases. If we take a look at a line like this, let's say that this is the x-axis on the horizontal and the y-axis is the vertical here. And let's say that the line starts at 0 for both of these and ends at 2. The first point can be described as 0, 0, and the second point can be described as 2, 2. When we talk about points, x is the first point. So in this case, this 0 is x1 and this 2 is x2. Then after the comma we'll have y. So this will be y1 and this will be y2. If we plug this into our equation to solve for slope, we get m equals 2 minus 0 over 2 minus 0. Simplifying this, we get 2 over 2, which means our slope is 1. And that makes sense intuitively. We can see that every time we go 1 square in the positive direction on the x-axis, we also go up 1 square in the positive direction on the y-axis. So the slope of this is positive 1. Let's look at a negative slope now. A negative slope means y decreases as x increases or vice versa. If we look at this line here, this line shows a negative slope. Let's say again, this is the x-axis and this line starts at 0 and goes to 2, and this is the y-axis. Let's say that this is 0 here and the highest point is positive 2. Well, we can see now if we draw out the coordinates again, the line starts on 0, 2 and it ends at 2, 0. Again, this is x1, this is x2, and this is y1, and this is y2. Putting this in our equation here, we get 0 minus 2 over 2 minus 0. Simplifying this, we get negative 2 over 2, which simplifies to negative 1. So here our slope equals negative 1. Again, intuitively this makes sense. Every time we go to the right in the positive direction on the x-axis, we're actually going in the negative direction 1 square on the y-axis. So this slope is negative 1. An undefined slope means y changes despite x not changing, and this is shown as a vertical line. If I draw a line here going straight up and down, then it means that the delta x here, the term on the bottom, is going to be 0. No matter what delta y will be, this number has to be undefined because you can't divide by 0. A slope of 0 means y does not change as x changes, and this is shown as a horizontal line. Again, if the delta y is 0, it doesn't matter what we divide it by, whether it's 1 or a million, that number will always be 0. A small slope is not steep as it is close to 0. If I have a slope of, let's say, 0.5, it means every time I go over to the right 1 square, I only go up half a square on the y-axis. So if I was to draw this line now, it would look something like this. This slope is not very steep because the slope number itself is actually close to 0. A large slope is steep as it is farther from 0. If I have a slope of 2, it means every time I go over 1 square on the x-axis, I go up 2 squares on the y-axis. So if I was to draw this line, it would be a very steep line. Tangent lines can be drawn on curved slopes to give us the instantaneous rate of change. If I have a graph which looks like this, we can see the slope is constantly changing. We can draw a tangent line to give us the instantaneous rate of change at any point. For instance, we can see here that the slope becomes flat. That means at this point, the slope is 0. If I draw a tangent line at this point, when the slope is positive, I'm going to get a positive slope, because as x is increasing, y is also increasing. Or if I draw a tangent line here to look at this slope, I can see that the slope will be negative, because as x goes in the positive direction, y goes in the negative direction. There are 4 types of slopes you should be familiar with. In the top left, we have a linear slope, which just means that the x-axis and the y-axis are increasing linearly, and that the slope is a straight line on this curve. In the bottom left, we have an exponential slope. We can see the slope is increasing more as x increases. If we draw some tangent lines, we can see at x equals 1, the slope is almost 0 because it's very flat. However, at x equals 4, the slope clearly becomes positive, and then at x equals 5, the slope almost becomes a vertical line. This is an exponential slope. In the top right, we see a semi-log slope. One of the axes, in this case the x-axis, is on a linear scale. Every tick mark on the x-axis increases by 200, and then the y-axis is a logarithmic scale. We can see that the first tick mark is 10 to the 0, or 1. The next tick mark is 10, and then the one after that is 100, and the one above that is 1,000. The tick marks on this axis aren't increasing linearly. They're increasing logarithmically, so this is a semi-log. On a log-log graph, both scales will be logarithmic. Next up is the multiplication table. You should have this memorized. This is crucial for fast math, and if you don't have this memorized but you want to get started, I recommend starting with the rows and columns with number 5, because most numbers can be rounded to something you can multiply by 5 or 10. So that's where I would start. But you should have this whole thing memorized. It's going to make your MCAT math so much easier and so much faster. And I can't emphasize this enough. Significant figures show how precise a measurement is. 5.00 grams is more precise than just 5 grams because 5.00 has 3 significant figures and 5 only has 1. The rules you should know for sig figs is all non-zero digits are significant, zeros between significant digits are significant, leading zeros are not significant, and trailing zeros after a decimal are significant. These rules can be summarized by saying, if it can be ignored in scientific notation, it's not significant. For this first example, 0.504, we have 3 significant figures because we have 2 non-zero digits and then a 0 in between them. If we were to write this number in scientific notation, we would write 5.04 times 10 to the negative first. I want you to work through these next two using the rules we have above and see if you can see how this one has 2 sig figs and this one has 3 sig figs. One point I want to make while we're here is sometimes you can't tell how many sig figs a number has unless it's explicitly stated. For this number here, 5,400, you may think it has 2 sig figs only because it has 2 non-zero digits here. If this has 2 sig figs, we would write it out as 5.4 times 10 to the third. However, this number could also be written as 5.40 times 10 to the third. This is the same number, 5,400, but because it's written out in scientific notation with 3 sig figs, 5.40, you know it's going to have 3 sig figs. And you can only tell that 5,400 has 2 sig figs or 3 sig figs in this case based on how it's written in scientific notation. Someone would have to tell you this. Otherwise, you can just assume it has 2 sig figs. Unless you see this decimal point here. If you see a number written out like this with a decimal point and no numbers after it, it means that all 4 of these numbers are significant. So in this case, you know that this number has 4 significant figures, and therefore it must be written out in scientific notation like 5.400 times 10 to the third, again with 4 sig figs. Practice with these a little bit, understand the rules, and you'll get these down pretty fast. Alright, some miscellaneous math things I think you should know. You should know your square roots and your exponents too. These are crucial for fast math. On the right, I've included 2 tables with the common numbers squared, what those results are, and then the square roots of those numbers bringing you back to that number. For instance, 3 squared makes 9, and the square root of 9 makes 3. You should be familiar with going back and forth on both of these for every number between 1 and 12. One other thing you should know is 2 square roots multiplied together make that original number. If we multiply the square root of 2 by itself, that's the same as saying the square root of 2 squared. The square root and the square cancel out, and so this just makes 2. And we can see that in division as well. Ratios compare 2 separate quantities without combining them into a total. If you have 5 children in a room, and 2 of them are boys and 3 of them are girls, This is a 2 to 3 ratio. Notice that 5, which is the total number of children, is not included in this ratio. A proportion sets two equal ratios or fractions side by side. For instance, if we have this 2 over 3 ratio, and this ratio was kept the same, but imagining there was double the amount of children in the room, we know that there would be 6 girls, and a proportion could help us find how many boys there would be in this room. You could do algebra to solve this, and you would find that there would be 4 boys for 6 girls in this room. Probability describes how likely an event is to occur. Probabilities range from 0, which means it won't happen or it's impossible, to 1, which means it will always happen or it's certain. For multiple independent events, you need to multiply their probabilities. The most common one you'll see is, assuming a couple has 2 children, what are the odds that both of them are boys? The probability that the first child will be a boy is 1 in 2, and then the probability that the next child is also a boy is still 1 in 2. These are independent events because the second child is not influenced by the first child. So we multiply these together and we see that the probability is 1 in 4. Percentages express numbers as a fraction of 100. Percentages are reversible and readily change into fractions. For instance, 1 in 4 is a fraction, but we could easily convert this and quickly to 25%. Let's work through some examples of this now. If I was asked for 75% of 800, I would solve this using fractions, because I know 75% is the same as 3 over 4. So multiplying this by 800 is simple. 800 divided by 4 is 200, and then 200 times 3 is 600. So we know 75% of 800 is 3/4 of 800, or 600. If I was asked for 2.5% of 400, I would use a trick I call the 1% trick. I know that 1% of 400 is 4, and then I need 2.5 times that. I multiply those together and I get 10. 2.5% of 400 is 10. Lastly, this is a great example to demonstrate how percentages are reversible. If I was asked for 12% of 50, this initially seems like it would be pretty hard to calculate using the 1% rule or using any fraction rule, but because percentages are reversible, this question is the same as asking for 50% of 12. That is much easier. Half of 12 is just 12 divided by 2, which equals 6. So 12% of 50 is 6. And that concludes our lesson on math fundamentals.